This is Ms. Now. We're continuing our unit on stoichiometry. Make sure you have out paper, pencil, calculators, and your periodic table. So what you see in front of you now is what we kind of refer to as a mole map. So this is just a visual of starting with, say, something like if you start with mass, how to convert to moles would be going 1 mole is equal to the molar mass. You can get to moles. If you were in volume here, how would you get to moles? You would do 1 mole equals 22.4 liters. So this is just kind of show you all the map of the conversion factors you would use to go from various units such as mass, volume, or representative particles. Representative particles being atoms, ions, all being 6.2 times 10^23. But this is just a little map. It's a nice little visual map that you can use. We tend to use the dimensional analysis, and some students like to kind of look at this to have all their conversion factors in one place. Reminder, what is the volume of 1 mole of a gas? And this would be at STP. The volume of gas changes when pressure and temperature change, but gas volume is standardized. So at standard temperature and volume, 1 mole of any gas is 22.4 liters. We've had this conversion factor before, so 22.4 liters of a gas is 1 mole of gas particles, whatever that gas may be, so make sure you remember that one. All right, so this is just a fictitious reaction in which you have 2 moles of compound AB plus 3 moles of compound CB gives you 6 moles of AD plus 1 mole of BC. All right, so you would still use this little dimensional analysis form of converting. If you started out in volume, you still want to get to moles. If you start out in mass, you still need to get to moles. If you start out in representative particles, you still need to get to moles. But how do you hop from one substance to another? You're going to use this mole ratio. And this mole ratio, remember, comes from the balanced equation. So still want to make sure you're balanced. You still want to make sure you balance your reaction first. And then after you do the mole ratio, you can still use this method using dimensional analysis to go to whichever unit you want. Once you're in moles, you can go to representative particles, you can go to volume, or you can go to mass. All right, so let's work some of these. So let's get to it. All right, so this says you have water plus sodium oxide gives you sodium hydroxide. So let's go ahead and get this thing balanced, because that's the first thing you always want to make sure that you balance the equation. So if we put a 2 here, it looks like my sodiums would be balanced. And then if I, let's see, I think that would be balanced all the way. So you have 2 hydrogen, 2 hydrogen, 2 sodium, and then 2 oxygen, 2 oxygen. So, yep, I think that's balanced. So you only balance the equation, set up stoichiometry, and calculate the molar mass of each substance. So once the equation is balanced, that's the first step of stoichiometry, then we're going to go to doing dimensional analysis. So it says how many grams of sodium hydroxide. Okay, so this is what we're looking for. Produced when 12.5 grams of water. So let's start by writing down our 12.5 grams of water. And then whatever unit's up top is going to go down the bottom. If you're not in moles, we need to get to moles. We're going to go to moles of water. We've done this before. And 1 mole of water, you would calculate the molar mass of water, and that ends up being 18.02. We cross this out. If we stop here, we would be in moles of water, but we want grams of sodium hydroxide, so we have to keep going. Whatever unit's up top comes down on bottom. So now that we're in moles, we can go to moles of whatever it is we're looking for. This is the mole ratio, so we're looking for moles of sodium hydroxide. And then remember, we get this mole ratio from the balanced equation. So the number in front of water up here is a 1. This is an understood 1. You can put these in here, I guess, for you, but there is an understood 1 then. Sodium hydroxide is 2. Those cross out. If we stopped here, our answer would be in moles of sodium hydroxide, but we want grams of sodium hydroxide, so we have to keep going. And whatever unit's up top comes down on bottom. And now we can go to grams of sodium hydroxide. And 1 mole of sodium hydroxide is equal to the molar mass of sodium hydroxide, which is 40.0. Now we stop here because we want grams of sodium hydroxide and then grams of sodium hydroxide. So then we multiply everything across the top, 12.5 times 1 times 2 times 40, divided by 18.02, divided by 1, divided by 1. And when we do that, we find our answer is 55.5 grams of sodium hydroxide. I did pay attention to significant digits. There's 3 here. Our molar masses each have 4. And this here is an infinite number, so we don't look at it for significant digits because they're exact numbers. How many liters of hydrofluoric acid gas are needed to produce 9.4 liters of hydrogen gas, H2, at STP? So the first thing we need to do is make sure our equation's balanced. So I can see that there's 2 fluorine on my product side, so I need to put 2 here. And that's balanced. Okay. So we're going to go ahead and write down our given, which is 9.40 liters of hydrogen gas. I also tend to do this thing where I do how many liters, so I know that's what I'm looking for, right? And I tend to underline my given, okay? All right, so I'm going to do brackets here. So whatever units up top comes down on bottom. If you're not in moles, you need to get moles. We're in liters, so we need to get to moles. So we're going to go to moles of hydrogen. And this relationship is that 1 mole is equal to 22.4 liters at STP. That's the conversion factor you should know from last semester. If we stopped here, our answer would be in moles of hydrogen, but we want liters of hydrofluoric acid, so we have to keep going. Whatever unit's up top comes down on bottom. And then we can go to moles of HF. And the way that the place we find our mole ratio is in our balanced equation. So what's in front of HF is a 2. What's in front of hydrogen is a 1. Now we're in moles of hydrofluoric acid, but we want liters, so we have to keep going. Whatever unit's up top comes down on bottom. And we know the relationship here is that 1 mole equals 22.4 liters. And so when we multiply 9.4 liters times 1 times 2 times 22.4 divided by 22.4 divided by 1 divided by 1, we get 18.8 liters of HF. That's your final answer. I did pay attention to significant digits. Okay, remember the mole ratio is an infinite number. We don't need to look at it. Right, mass to volume. This one, the reaction's already given to us, and it's already balanced. We check to make sure it's balanced all the way. It is. So it says how many liters of nitrogen, so that's what we're looking for, are formed when 228 grams of ammonium nitrate is decomposed at STP. So we'll start with 228 grams of ammonium nitrate. And if you're not in moles, we need to get to moles. Right. Okay. That relationship is that 1 mole is equal to the molar mass, and the molar mass is 80.06. Now that we're in moles of ammonium nitrate, we can go to moles of what we're looking for, which is nitrogen. So whatever unit's up top comes down on bottom. And we get this mole ratio from the balanced equation. So what's in front of nitrogen is a 2. What's in front of ammonium nitrate is a 2. Just cross it out. If we stopped here, our answer would be in moles of nitrogen, but we want liters, so we have to keep going. Whatever unit's up top comes down on bottom. 1 mole equals 22.4 liters. So we're left with liters of nitrogen, which is what we want. And so when we multiply everything across the top and divide it by everything across the bottom, we get 63.8 liters of nitrogen. I did pay attention to significant digits. I did write my unit and substance each step of the way. And you notice that what we're doing here, the only new thing that we've added is the mole ratio. You've been converting to moles, and you've been converting to volume, and you've been converting to other units for several units now. Right, this concludes video 2 on stoichiometry. You should have taken high quality and in-depth notes with examples, rewatch the videos needed, and ask questions.